Hello everyone, welcome to the Kore.ai platform overview. In this video, we'll walk you through the different stages of the virtual assistant lifecycle using the Kore platform. Kore.ai platform provides the required components and capabilities you need to build sophisticated virtual assistants. Kore Virtual Assistant Platform offers a unique blend of conversational chat interface and digital user experience. Kore.ai is a low-code, no-code platform that helps enterprises to design, build, test, and deploy AI-powered virtual assistants. The intelligent virtual assistants developed on Kore.ai Virtual Assistant Platform can satisfy complex enterprise use cases, accelerate time to market, and exceed customer expectations. In this video, we'll look into the following steps of a virtual assistant lifecycle: designing a conversation using conversation design, building the virtual assistant using the task execution framework, digital views, UI forms, and small talks, training the virtual assistants using the NLP engines. We shall cover the machine learning engine, fundamental meaning engine, and knowledge graph engine. Testing the virtual assistant using batch and utterance testing. Publishing the virtual assistant. Configuring the virtual assistant using the bot management console. And analyzing the performance and user interactions using conversation flows and custom dashboards. Let's look into the different components and features of the platform. As a user, you must have an account in the bot builder of the platform. Once you log into the platform with your credentials, you come to the landing page of the bot builder. You can see all the bots developed by you and share with you on this page. You can start building a new bot by clicking on the New Bot button. When you build a new bot, you must provide a name to the bot, the language in which you want to build the bot, and the type of the bot. Kore.ai platform supports more than 19 languages to build virtual assistants. The virtual assistants have the capability to auto-detect and switch language based on user utterances. Let's take a look at a predefined bot. When you open a predefined bot, you're taken to the bot summary page. The bot summary dashboard gives users a bird's eye view of the bot properties and provides users with all the important information about the bot's configuration, such as task details, knowledge graph details, small talks, details on the NLP training, channels used, developer details, change logs, event details, variable details, and many more. Before we start building a virtual assistant, let's look into the Storyboard feature of the Conversation Designer. Storyboard is the simplest and most natural way of designing a virtual assistant that's used to capture complex requirements. When you open a storyboard, you can define scenes to represent each use case identified for the bot. Within a scene, you can design an entire conversation. As you can see over here, a conversation has been designed, and within that design, we have laid out a series of bot and user conversations. Once the conversation is designed, you can see the preview of the final bot. This preview will show how the bot will look after it gets published. This conversation design can also be shared with other stakeholders for their review and approval. Once approved by all the stakeholders, this design can be used to build the bot. Now, let's look into the task execution framework from where we can build different tasks for the virtual assistant. With a virtual assistant, different types of tasks can be enabled. The first one is the dialogue task. Dialogue tasks are used to design and build complex multi-turn conversational experiences. As you can see here, multiple tasks have been defined for the virtual assistant. Let's look into the task that is created using the design of the storyboard. When you see the actual configuration of the task, it looks like an interconnection of several nodes that are available with the developers to define a conversation. For instance, we have an entity node to capture the information from the user, a message node to display a message, script node to add JavaScripts within our conversation, service nodes to make API calls, and many more. Using these nodes, we can define an entire conversation within a dialogue task. Similarly, we have created multiple dialogue tasks, representing each use case which has been identified for the virtual assistant. The same virtual assistant can also be configured to respond to frequently asked questions using the knowledge graph. If you look into the configuration of the knowledge graph, you can see a list of questions and responses added. You have to train the knowledge graph to enable the virtual assistant to identify the questions correctly. The bot ontology created for the virtual assistant is a structure of key domain terms that are used to identify the intents accurately and efficiently. Now, let us see how we can build small talks within our virtual assistant. Small talks are designed to handle the casual conversations which are not meant for dialogue tasks or knowledge tasks. The custom small talk UI editor provides an easy-to-use interface for quickly generating multiple scenarios by simply providing the user and bot utterances. As you can see here, we have a group named Greetings. Using this, the virtual assistant can handle all the greetings coming from an end user. Responses to these greetings, such as hello, hi, thank you, goodbye, etc., can be configured using the small talk feature. As a developer, you can define and train the virtual assistant with the relevant small talks. The next feature of the platform is the UI forms. UI forms provide a list of input fields required for capturing details from end users. The UI form designer has all the required features and components needed to develop virtually any form specific to your business needs. Components such as drop-downs, labels, tooltips, separators, and more can be simply dragged and dropped to create the forms. The properties of the component can be defined here as per your requirements. The next feature that can be added to the virtual assistant are digital views. Digital views can be used to design interactive components that proactively present relevant information to your customers and employees. Unlike regular chat or messaging app-based interactions, digital views provide an appealing and intuitive interface to boost user engagement. Digital views provide the end users a unique blend of conversational experience and digital experience. As you can see, we have used different panels and widgets, such as pie charts, tables, lists, etc., for deeper interaction with the users. The form created using UI forms can also be displayed in the panels. Once the tasks have been defined within the virtual assistants, the next step is to train the NLP engine. Kore.ai's proprietary NLP technology detects intent of users in the given context and extracts entities with a very high accuracy by processing user inputs against 3 different engines. The first is the machine learning engine, which uses statistical modeling and deep neural networks. The second is the fundamental meaning model, which considers parts of speech and inbuilt concepts to identify each word in the user utterance. Finally, the third is the ontology-based knowledge graph model that uses a hierarchical structure of key domain terms. This unique approach allows our virtual assistants to not only understand a user's input with a high degree of accuracy, but also to intelligently handle complex human conversations. Machine learning engine can be trained by providing multiple training utterances for a particular task. We select a task over here and then provide all the possible utterances that can come from the user. Fundamental Meaning Engine, or the FM engine, is a semantic rules-driven engine which uses synonyms and patterns. To train the FM engine, we select the Synonyms section and choose the synonyms of the keywords. This will enable the virtual assistant to identify the intents even if the user uses synonyms in their conversations. Similarly, we can also train the FM engine with patterns. If a pattern matches with the user utterance, then that particular intent gets qualified as a definitive match. Kore.ai's platform gives you multiple operators to define patterns with ease. The platform also gives you an option to define the traits that can be used to mention specific words which, when present in the user utterance, can drive intent identification. By using thresholds and configuration buttons, you can manage and configure the threshold level of the ML engine, FM engine, KG engine, and the ranking and resolver engine. In the natural language component, we also have the intelligence section. In this section, we can define the interruption handling of virtual assistants. Using the interruption handling feature, virtual assistants can identify a new intent even in the middle of a conversation. Meaning, if the user interrupts a particular conversation and queries for anything new, the virtual assistant will be able to identify it. The virtual assistant can be trained to be intelligent enough either to hold the current intent and execute the new intent, or execute the current intent first and the new intent after that. You can also configure the amend entity feature here, which enables the virtual assistant to understand the context of the request, identify the entity to be amended, and act upon it directly, all without writing a single line of code. The Kore.ai virtual assistant platform also enables virtual assistants to handle multiple intents at a time. This allows you to have a natural conversation with the virtual assistant with multiple queries in a single utterance. The platform also has a sentiment analysis feature that allows virtual assistants to understand the mood of the user and respond accordingly. Kore.ai's NLP engine parses user utterances for specific words, phrases, and modifiers corresponding to different emotional states. The platform analyzes user utterances and classifies them based on detected levels of anger, disgust, fear, sadness, joy, and positivity. The platform ranks the sentiments on a scale of -3 to +3 to steer user and bot conversations. Under natural language, we also have a section for default conversation. Here, you can configure the welcome events based on specific channels, events of task failure, and also events at the end of the conversation. So far, we have seen how to create tasks and train the virtual assistant. In the next section, we will discuss how to test them. Kore.ai platform provides two ways of testing the virtual assistants, utterance testing and batch testing. In utterance testing, you can test the virtual assistants on a variety of user inputs. When you test a user utterance against a virtual assistant, the NLP engine tries to find the bot tasks that match the intent. The NLP engine uses a hybrid approach using the ML, FM, and KG models to score the matching intents, which then goes to the ranking and resolver engine to determine the winning intent. Developers can also perform batch testing before the deployment of the virtual assistant. Using batch testing, you can upload a test suite that contains multiple utterances to be tested against the virtual assistant. A report gets generated showing which intents are identified for utterances. Using batch testing, developers can get an idea of how well the virtual assistants are trained to converse with end users. Once tested, you can enable channels for the virtual assistants through which the end users can connect. Kore.ai platform has built integrations with more than 30 channels, which comprise almost every popular social and enterprise messaging channel, voice channels, and customer service channels. Once a channel is enabled, the bot can be published to the end users. The low-code platform enables developers to verify the tasks, languages, NLP components, API extensions, and other bot settings that they want to publish. Once the virtual assistant is published successfully, users can connect to the virtual assistant over the selected channel and converse with it. Once the virtual assistant is published, it's vital for organizations to monitor overall bot performance, analyze failure scenarios, and periodically retrain their virtual assistants to ensure a high-quality service. This can be done in the Analyze section of the platform. You can analyze using the conversation flows and bot metrics options available on the platform. Conversation flow provides a visual representation of the user journey. You can see what are the different tasks performed by the bot and click on them to see what are the user utterances for which those tasks were triggered. You can click on the task to deep dive into the user's journey. The other report under Analyze section is the Metrics report. Using this, you can see the report of what intents are found, not found, failed tasks, performance, and many more. Under the Intents Found section, you can find the user utterances and the intent to which the utterances were matched. Upon clicking any one of the utterances, you can see the details of those utterances, channels, entities, etc. You can check the NLP analysis section to identify which NLP engine identified the task, and you can also see the entire chat history using the chat history option. Intents not found section shows all those utterances which failed to match to a particular intent. Under this, if the developers find any of the correct utterances should be matched to a particular intent, then they can trigger the training of the NLP engine directly from here using this train option. Failed task shows all the utterances whose execution failed. The performance section shows the performance details of the API calls and the script nodes. The time taken for an API call or the time taken to execute a script can be analyzed in this section. The next section of the platform is the settings section, where we have the config settings and the bot management settings. Config settings allows developers to configure the general settings of the virtual assistant, its languages, PII settings to redact sensitive information, define global or content variables to be used in the task configuration, and define authorization profiles to be used with the API calls. In the bot management section, developers can share the virtual assistant with other developers. Developers are also given options to export a bot, import a bot, and see the change logs. Developers can also track the different versions of the virtual assistants using the versioning feature of the platform. Versioning allows developers to create multiple versions of the virtual assistant at various stages of its life cycle. These versions can be retrieved and restored as and when required. The virtual assistant can also be deleted before it is published to the end users using the delete bot option. The platform also has dashboards to explore different reports. The bot summary, which we have seen before, shows the entire configuration of the bot on a single page. Usage metrics provide the real-time status of the virtual assistant. This includes the number of active users and channels on which the virtual assistant is active. You can also customize the duration for which you want to see the details of the task performed in sessions. Besides this, you can also get graphical representation of the task performance using the bot metrics. You can also build dashboards to generate your own reports to meet specific business needs using the custom dashboard feature. The platform also has a section called API extensions, using which we can enable the bot kit. Bot kit is an additional layer between the bot and user, which allows developers to have better control over the interaction with the end users. Bot kit also allows developers to integrate with any third-party applications. We can also configure agent transfer and the APIs exposed by the Kore.ai virtual assistant platform. We also have a feature named Data Table within the platform. Using data tables, storing and retrieving information can be further simplified. We can select the data option directly from the bot builder to define the data table and click on the new table to create a new table. Let's look into one of the already defined data tables. The table named User Account, which can be used for the purpose of storing the information provided by the user. We can provide the details of the table and then add columns to the table. Here, we have added relevant columns such as account type, account name, balance, account ID, etc. The bot is assigned to the demo banking bot. Once the data table is created, we can define tasks within the assigned bot that will be using the data table. Using this feature, you can also join the data tables, manipulate the data, and securely import or export data tables. Data tables thus take care of your data needs without having to depend on external services. This was a quick overview of the Kore.ai platform. In this video, we looked at the following platform features: Conversation Designer, Dialogue Tasks, Knowledge Tasks, Digital Views, and the UI Form. NLP training, in which we cover machine learning, fundamental meaning, and knowledge graph. Platform intelligence features, which cover dialogue management, context management, and sentiment management. Utterance and batch testing. Channel enablement. How to publish the virtual assistant. dashboards to analyze the performance of the virtual assistants and usage metrics, API extensions, and data tables. Starting from designing the conversation to build, train, test, deploy, and analyze the virtual assistants, Kore.ai provides you a robust, fully equipped, and end-to-end platform for all your enterprise needs. Explore our low-code, no-code platform to build your own virtual assistants. You can also sign up for online training from the Kore.ai University and get trained by our team of experts. Visit our developers page to learn more. Thank you for watching.